Okay, so today's lesson 9-2, graphing quadratic functions from factored form. So you should be familiar with factored form because we spent Unit 8 learning how to factor quadratic equations. So a quadratic equation is an equation, as we talked about in the last section, that has a second degree. So we're going to look at this first example here and say, okay, how did we factor this in Unit 8? And we reviewed it on Khan Academy this past week, and we did a section, if you did participate in last week's lessons, we did a section on the zero product property. So this should be familiar. If you don't remember how to factor and do the zero product property, the video is on my YouTube channel from last week, or if you go into assignment under zero product property, you could find the video and practice this some more. So we're solving the equation zero product property. It's a trinomial, which means we do the x. So first times last, -6. The middle term is +1. What multiplies -6 and adds to 1? 3 and -2. And I'm going to use a split the middle method. For those of you who know the shortcut, feel free to use it. We're going to replace the middle with 3x minus 2x because that's equivalent to the 1x. We're going to bring down the x squared and the -6, and we're going to group. So we're going to group the first two and the last two. GCF here is x plus 3 when we factor. Over here it's -2, and we get x plus 3 when we factor. And then from there, our common factor, we smile because it's the same, x plus 3. We cross it out, and we get x minus 2 as the other factor. This is called factor form. We're going to take each of the factors and set them equal to 0. So x equals -3. And then if we do x minus 2 equals 0, x equals 2. So those are the solutions to this equation. So we took the equation, we found the solutions. We also call these zeros, okay, or solutions, okay, to this quadratic equation. So now we're going to look at this next equation. Consider the equation y equals x squared plus x minus 6. Notice the similarity in this equation. The only difference is the 0 and the y. Okay, so we're looking at a quadratic equation, and we're going to talk about how to graph this. So given this quadratic equation, what we want to do is figure out where the points where the graph crosses the x-axis. And if you remember, these points where the graph crosses the x-axis are called the x-intercepts. Okay, so if we think about where it crosses the x-axis, those are called the x-intercepts. And at the x-intercept, the y value is always 0 because we don't go up and down. So y is always equal to 0 at the x-intercept. The coordinate is always x comma 0. Okay, so if we're looking at this equation and we say, well, where does the line cross the x-axis? We know y has to be 0. So we're going to rewrite this equation, but replace the y with 0. And then we're going to solve. Now we've already done this because if we look up here, this is the same equation we had. So when we solve this, we get x equals -3 and x equals 2. So the x-intercepts are at -3, 0, because the y value is 0, and at 2, 0. So those are your x-intercepts. On the graph, we can put a point at -3, 0, and at 2, 0. And we have our graph with our x-intercepts. So the x-intercepts and the zeros and the solutions are kind of all interchangeable. The word depends on what we're talking about. If we're talking about graphing, we call them the x-intercepts. If we're solving equation, the solutions. And if we're working with a function, they're the zeros. They're all kind of interchangeable. So now once we have those 2 points, graphing quadratic equations involves symmetry. We talked about the axis of symmetry in the last lesson. How can we use that to find the vertex? So let's start with thinking about where is the axis of symmetry. The axis of symmetry is equally split between any 2 points that are on the same horizontal value. So these are at the same horizontal value. The axis of symmetry must split them in half. And so I'm going to count inward, count my boxes till I find the point right in the middle, which in this case is at -1/2. So it's between the 0 and the -1 or -1/2. Yesterday I did these in highlighter, so I'm going to do that again. So our axis of symmetry is going right down the middle here. So we want to find the axis of symmetry first. So let's write that down. The axis of symmetry is at x equals -1/2. Okay, so we know that value, but we want to find the vertex. And if you remember yesterday, the vertex is always the axis of symmetry for the x value, and then we find the y value. So how can we find the y value? You might say, I have no clue, but there is a way to find the y value because we have an equation. So we want to find the y value knowing the x value is negative 1/2. So we're going to write the equation. Y equals negative 1/2 squared plus negative 1/2 minus 6. So I'm taking the equation that we're given, the equation we're working with, and I'm replacing the x with the x value that we know. And if we solve this, negative 1/2 squared is the same thing as negative 1/2 times itself. Negative 1 times negative 1 is positive 1. 2 times 2 is 4. And then we're going to add to that negative 1/2 and minus 6. Negative 1/4 minus 1/2 is negative 1/4. Minus 6 is negative 6 1/4. So that is our vertex, negative 6 1/4. We're going to go to our graph and point the point negative 1/2, negative 6 1/4, right on that axis of symmetry. So now we have that point. So let's continue. How can we find the y-intercept, where the graph crosses a y-axis? And if we're on the y-axis, the x value, it doesn't go side to side at all, is always 0. So now we're going to use the equation again. We're trying to find the y value if x is 0. So we're going to go back to the equation. We're going to plug in 0. And y equals 0 plus 0 minus 6. Y is negative 6. When x is 0, y is negative 6. So now we can plot that point. 0, negative 6 on our graph. And then it says, what else can we say about the graph based on our knowledge of symmetrical nature of the graph? Can we determine any other point? So if we think about this as an axis of symmetry, every point can reflect over it. These points are already reflected. The vertex is on it, but that point we just created, we can reflect over the axis of symmetry. And at negative 1, we have a point at negative 6. And now we're going to connect our points to create our graph. I always say the rule for graphing a quadratic is you need 5 points to make the graph. Okay? So now let's look at the next page. You are going to graph A, B, and C after I show you the whole process on D. D looks like the most complicated, so that's what I'm going to show you. Okay? So let's go to D. And we're going to look, I'm going to zoom in a little bit there. So the first thing we have to do, just like we did on the previous page, is find the x-intercepts. Because we can't find the axis of symmetry or anything else till we have some points. To find the x-intercepts, we're going to replace the function value. So we can replace the p of x is sort of like the y with 0. And we're going to have negative 6x squared plus 36x minus 30. And we're going to factor out this. And the first thing I'm going to do is factor out this GCF of negative 6. And I'm going to get x squared. Negative 6 times negative 6 is 36. And negative 6 times 5 is negative 30. And then we're going to make our x. 1 times 5 is 5. Negative 6. What multiplies to 5 and adds to negative 6? Negative 5 and negative 1. So we split the middle. And we get negative 5x and minus 1x. And we put the plus 5 and the x squared. And we're going to group. And over here we can take out an x and get x minus 5. And over here we can take out a negative 1, x minus 5. And so our factors are x minus 5 and x minus 1. If I set those equal to 0, I'm sneaking it in because I want to have room. I get x minus 5 equals 0, x is 5. And then x minus 1 equals 0, x is 1. Those are my values, or my zeros, which become my x-intercepts because I write them as a coordinate 5, 0, and 1, 0. And then I plot on my graph the points 5, 0, and 1, 0. So that's our first step. Find the x-intercepts by taking your factors and setting them equal to 0. That negative 6 in the front, I forgot, and you probably are wondering why I just made it disappear. The negative 6 in the front is also a factor, but when we set it equal to 0, the negative 6 doesn't do anything to the factor. It will be important when we start doing the rest of it, but negative 6 is not equal to 0, so it kind of disappears. So it doesn't affect the x-intercepts. It's going to affect the graph. So after we find the x-intercepts, axis of symmetry. So x equals, and it's the point right between. So we're going to work our values in. I promised to make these, or actually I don't think I said that to you, but I made sure I made the ones on this page not fractions, so you wouldn't have to worry about doing work with fractions like we did on the first page. So there's my axis of symmetry. It's at x equals 3, which is directly between 1 and 5. I'm going to highlight that again, or reflect all points over that. Once we have our axis of symmetry, we're going to find our vertex. To find the vertex, we're going to plug in 3 into the equation for x. So y equals negative 6 times 3 squared plus 36 times 3 minus 30. And I do this math out. Exponents first, so negative 6 times 9, 36 times 3 minus 30. So this would be negative 54. 36 times 3 is 108, and then minus 30. And if I continue to solve that out, 108 minus 30 is 78 minus 54. 78 minus 54 is 24. So our point is at 24, which I did this, I thought I fixed this, but this is, we're going to have to make this count by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, so that it fits. So we're going to go vertex up at positive 24. Okay, so the coordinate is 3, 24. Okay, and then the next step after we have our vertex is to find our y-axis. So our y-axis in this case is going to be, remember the y-axis, or y-intercept, not the y-axis. The y-intercept is the point when x equals 0. So we're going to go back to our equation. We're going to put y equals, and we're going to plug in 0 for all the x's. 0 squared plus 36 times 0, and then minus 30. And that's going to give us 0 plus 0 minus 30, or negative 30. So if we're counting by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30 is right off the graph. If we reflect that, then we have another point over here, and then we can draw our curve. So you're going to use that same process. Again, find the zeros. Some of these are factored for you already, and some of them you have to factor. So A and C are already factored. B, you're going to have to factor. Take your factors, set them equal to 0 to get your values for x. Make those the x-intercepts. Find your axis of symmetry by splitting those in half, and then plugging that into the equation as x to get your vertex. Then you have your vertex, and then once you do that, you're going to find your y-intercept by setting x equal to 0 in the equation, and then solving for y, and then reflecting that point. So use that whole process.